But in this video, we're looking at quadratic functions. So a quadratic function has an equation in the form of usually y equals ax squared plus bx plus c, where the highest power of x is 2. All right, so the graph, when we graph these type of functions, it forms a parabola. Okay, so below you can see an example of a quadratic function, x squared minus x. That shape it's taken there is a parabola. Now, when we talk about concavity, we're talking about whether generally it is an increasing or decreasing curve. So if a is greater than 0 or positive, what we call that is concave upwards. It's going up, and it has what we call a minimum turning point. So what I mean by that is, if we draw something like this, it'll look like this, okay? And then this point down here, that is what we call our minimum turning point. Okay, it's sometimes called the vertex as well. So the minimum turning point is there. So again, if a is positive, then the parabola is concave upwards, or the way to remember it, if a is positive, the parabola forms a smiley face. So smiley face like that. Okay. Now, if a is less than 0, the parabola is concave downwards, and it has what we call a maximum turning point or a highest point, and it would look something like this. Okay, where the top part up here, that's going to be your max TP. Okay, so again, if a is negative, then we say that the parabola is a sad face. So if I wanted to draw that, if let's say a is -2, it would look something like this, and we'd have a sad face there. So again, if a is negative, sad face. If a is positive, smiley face. So the turning point that we were talking about also is known as the vertex, or later on you'll commonly refer to it as a stationary point. So the x value of the turning point is usually found by using the following formula, and you'll notice it's just part of your quadratic formula. It's the front part. All right, so xtp equals -b over 2a. So if I had something like in the form of ax squared plus bx plus c, let's say we had it's 3x squared plus 2x plus 4, we would substitute in our values. So our turning point would be at -2 over 2 times 3, so -2 over 6. That would be the x value of where the turning point is. Okay, if you wanted to find the y value for this, you would then substitute this into the original equation to get your y value. So here we have an example. We have a quadratic, and we're told to find the x and y intercepts. The x intercepts are the easiest by far. All you need to use is the quadratic formula, or factorize it down first. So if I wanted to factorize this, I get y equals x -8 x -1. Okay, because -8 plus -1 gives me that -9. -8 times -1 gives me that +8. Okay, so now that we got that, remember x intercepts occur, write this out, when y equals 0. So we have 0 equals x minus 8 and x minus 1. So if we focus on that front bracket, we have x minus 8 needs to equal 0, and on the back bracket it's x minus 1 needs to equal 0. So x equals 8, x equals 1. So that's where it's crossing the x-axis. We wanted to do our y-intercepts. The y-intercept, we know that is when x equals 0. And in this form, when you're trying to find the y-intercept, it's actually better to use the original. So before we did any factorization. And the trick is, I'll do the full thing first. We're going to substitute in x equals 0. But you'll notice something when I do that. 0 squared minus 9 times 0 plus 8. So y equals 8. So the trick, if you didn't notice it there, it's just your end constant. So this plus 8 here, that's your y-intercept. Right? It's the constant at the end. And that's for all of them. So really, you don't have to do the substitution part there. But there you go. We got our 2x intercepts and our y-intercept. So now we have to sketch a quadratic and find its maximum and minimum turning point. When you're sketching, we pretty much do exactly what we just did before. we want to find our x-intercepts. So what I'm going to do is I'm going to quickly factorize that, and we get x plus 4, x minus 1. So for the front bracket, it's x plus 4 equals 0, x minus 1 equals 0. So this x is going to be negative 4, this x is going to be 1. Our y-intercept, if you remember the trick, it's just the constant at the end. So the y-intercept is going to be my negative 4 up here. So y equals negative 4. If I want to find my maximum or minimum turning point, the first thing I need to know, just find out, is if it's a maximum or minimum. So we look over here, my x squared is a positive. So what that means, remember, positive is smiley face, and smiley faces have a minimum turning point. So we know it's going to be a minimum turning point. So the next thing we need to find is that x coordinate of where that occurs. So x equals negative b over 2a, where I'll change colors now. A is going to be here, b, c. So we get negative 3 over 2 times 1. So negative 3 over 2. All right, so that's when we know it's occurring. So if I quickly draw up a grid, and here's our quick grid, we're going to plot all our points. So we know there's something over here at negative 4. We know there's something over here at 1. We know it's crossing down here also at negative 4. So what I've done there is I've plotted my x-intercepts and my y-intercept. I also know that at negative 3, 2, there's going to be, so negative 3, 2 is about here. So this is negative 3, 2. I should probably try to find my y value for that point. So what I'm going to do is I'm going to go y equals negative 3 over 2 squared plus 3 times negative 3 over 2 minus 4 equals, occurs at negative 25 over 4, or if we wanted to just quickly write out at negative 6 to 5. Okay, so if I scroll down here, we know that negative 3, 2, all the way down here to about here, which is negative 6.25, that's where the turning point occurs, where those two things intersect. Okay, so if I had to quickly try to sketch this, it's going to come down through that point and then up like that. So that's a really quick sketch. So what we did there, x-intercepts, y-intercepts, and then found the vertex, put it all together and draw a curve connecting them.